Okay, well, I'm just going to continue about the whole concept of subnetting and the importance why it is that we need to know binary. And we will see how it rolls out as we go through this entire course, network management. So here I begin here with my place values, 1, 2, 4, 8, 16, 32, and 64, 128, 8-bit. And I have this IP address of 192.168.3.55. And what I want to do here today is to show you how the whole concept of finding the network address. But before we do the network address, of course, you would have to understand the whole concept of classes, which we're going to assume that this here is a class 24. What I mean by a class 24, basically what we are saying is that the subnet mask would be basically 255.255.255.0. So if you also actually write this out in binary notation, it means then that it will be 1, 1, 1, 1, 2, 3, 4. So that's the first octet, which represents 255. Then 1, 1, 1, 1, 1, 1, 1, 1. That's the next octet. Then 1, 1, 1, 1, 1, 1, 1, 1. That's the third octet. And then the last one is 0, so it'll be like 8, 0, 0. Alright? So if you also count out all these ones here, so this would be like a /8 here, right? This would be 8, and it comes up here, so it will be a /16 here, right? And then this here will be /24, so that's how we arrive at /24, because we have 24 ones that is actually with, as we counted up now, to represent the IP address of 255.255.255.0. Alright, so I'm just going to take my eraser tool and just erase basically these numbers on the top, and I'm going to write it over. So just press delete on my keyboard, because I want to make sure that you all understand this thing perfectly. So I'll just take back my pen and write it back here. 1, 2, 3, 4, 5, 6, 7, 8. And then there's 9, 10, 11, 12, 13, 14, 15, 16, /16. And then 17, 18, 19, 20, 21, 22, 23, 24. So we get the whole concept of /24. Alright? Now, what we're going to do here now is to show how the network is being found on a /24, which is basically easy because Class C subnet systems is very simple to understand. And a lot of students just grasp the concept of it over a period of time. So we're going to break this 192 into binary, which is basically 192 will be 128 plus 64. So we're going to put on the 128, and by now you should know how to convert to binary notation. So we have 1, 2, 3, 4, 5, 6, and we have 2 ones in the front, right? And then 168 now, we most likely will take the 128. We would definitely take off the next one, which will be 64, and then if you are supposed to minus the sum 64, then we'll get 32. After a while, this is come like second nature. And then we have the 0, alright, then we have another 1, and then 3 zeros here. I should have probably put it in a lot better. Let me see if I can best do this over for you also, because we need to line this up to the subnet mask on the bottom here. So we'll go again. 192, I'll put on this one here, put on that one, the rest will be off. Alright, so 1, 2, 3, 4, 5, 6, right, the dot here. And I'll put on the 128, take off the 64, the 32, take off the 16, and then I'll put on the 8, and then the rest will be off. You can double check this if you wish. And then when we look for a 3, that means we're looking to add the 2 and the 1, so the rest will be off. And I'll put on the 2 and the 1 here. And then 55 now, basically I would have both 128 and 64 off. Alright, so I have 128 and 64 off. I'm going to put on the 32 because it's greater than 55. I'll also put on the 16, right? Then I will take off the 8 and then I'll put on the rest. I mean, you can always double check this because by now you should know how to do binary conversion. So what I'm going to do here basically is a logical AND, alright? And then now is a process. I'm going to put it over here where in logic gates, where a true is equal plus a true is equal to a true, where a true plus a false is equal to a false, right? Where a false plus a true is equal to a false again, and where a false plus false is equal to a false. And you can actually look up this in Google. Logic gates with the intersection of a Venn diagram, even though this is the whole concept of ANDing. But nonetheless, as we move on now, so we're going to AND this to find the network address, which is basically 1 plus 1, which is true. So we're going to get a true here, 1 plus another true here. And then what happens at 0 plus, which is false plus a true. So basically every one of them will be off. Alright. Same concept here where we will get a 1 here, a false here, another true, a false, a true, and then false. Alright. So you're going to have a false here going right down. And then the last two will be true. Alright. And then with all these rows here, no matter what numbers on top here, everything will be false according to the logic gates. So basically the network address, if you were to turn this back into a dotted decimal notation, would be 192.168.3.0. Now pay particular attention to this. And this will be /24. This is how routers now interpret the network address for the for a particular network. In this case here, if this is a host 55 and you wish to get the network address for 55, it will be 0. And at this point we could also talk about the broadcast address. So the broadcast address would be basically 192. And we'll talk a lot more about the broadcast addresses and so on. 168.3, which is the last one, which is 255. So basically you cannot use 0 because 0 is a network address, and you cannot use a broadcast address. So basically you have a range of IP addresses usable from 1 to 254. Alright? Now what makes this a lot difficult now is when these numbers in the back here, /24, turns like probably into a /28 or something like that. Like let's put a 28 here, or 27, or /29 or /30. This is when it becomes now classless subnetting. So I guess during the period of the course we're going to be talking a lot more about this, the whole concept of the classless number. We just discussed the whole idea of class full subnetting.